IoT is a word that is hard to grab somehow. IoT is all about buzzwords, and it's really hard to bring that topic into life. And on this slide, I tried to put on some topics which we see as quite important, or the most important topics in this IoT area. So of course, IoT is all about open standards and big data, central management, security, distributed intelligence, internet and services, and scalability and configuration. And the center of all, of course, people or the key players and all that. And as you see there, IoT is built up with a lot of components, with a lot of tools, software, devices, and it's really hard to understand how you can realize applications in there. And what I want you to understand is that CODESYS really is the ideal platform providing all essential technologies for building up those applications in IoT environments or in Industry 4.0. So, of course, we provide our runtime systems on any operational systems you can imagine, or CPU controllers. We have our field bus stacks, of course, one of the important players, our development systems, and as a new product, our Industry 4.0 platform, the automation server. IoT comes up with a lot of more topics. So when you think on security, like SSL or HTTPS, different communication protocols, and there's really a lot of tools, protocols, topics arising in that field. And we have really a platform which provides you components for all of that. And of course, a key player of IoT platforms is communication. And communication comes in different shades. So the origin of our CODESYS platform is in this area below here. So the classical communication takes place between the PLCs and the inputs and outputs or sensors and drives. And this is what's called field level communication. And this place, typically the field buses comes in. So we have, of course, also stacks for the common industrial field buses like EtherCAT or Ethernet IP, Profinet, CANopen, Modbus. And the important thing about our stacks is that they are written in IEC 61131 languages, so in CODESYS languages. And this is a big advantage compared to the stacks written in C, because we can bring them to the devices with the application on nearly any device. So we have this platform independence, and this is quite important. So of course the machine-to-machine communication plays a big role, and also there are different communication protocols come in place. So for instance, we provide the network variables here, And now our new product, OPC UA, pops up, to which I come back later. Then, of course, you have the classical communication from the development system to the controller, bringing the application down to the controller. And you have the possibility to have a visualization connected to your controller system as a web visualization or as a target visualization as a device located at your machine, or also as a HMI, so a standalone visualization in a central management system. And newer or in the latest years or the last years, additional communication paths arise. So there's a new player who came in called the edge and the cloud. And now machine data is transferred to those devices and cloud platforms. And of course, it is important to transfer data to those devices in a secure way, in a fast way. And that's the reason why also newer and communication protocols arise. And of course, also the cloud platforms communicate with each other, and you can imagine that even sensors here down at the field level could communicate with the cloud above. So it's all about communication protocols. And as you can imagine, if so many players are in that game, many languages or protocols play a role. And with our software libraries, we provide many of those protocols needed here. So let's start with the CODESYS IIoT libraries. And what is it? So CODESYS IIoT libraries is a set of libraries for communication on the one hand, and on the other hand for reading and writing of data structures needed in communication. And as well as our field bus stacks, those libraries are written in IEC language. And again, that's really a big advantage, because you can bring those libraries to any controller, to any device running a CODESYS control. And that's a big advantage. So, and you know, there are also a lot of players in these field, like Google or AWS, Azure, and a lot of protocols like SNMP and SNTP or MQTT. And we have libraries for all of that technologies of players. So let's make a deeper dive in these libraries. So at first, I want to start with the library called Web Client. What is a web client? Okay, the web client enables a CODESYS controller to communicate with a web server somewhere in the internet. And the communication is possible via HTTP or HTTPS. And what does this library provide? So you can request data from a web server. You can, of course, submit data to a web server. You can even delete data from a web server. You can return HTTP headers, and we support the most important authentication mechanisms, which is HTTP basic authentication or OAuth authentication version 1 and 2. And what we provide basically with all our libraries is a sample project, and always with a small visualization. So of course, you have the library, the function blocks there, which you can use to write your program and to build your functionality on the controller, to build your application. But as well, we provide always a little visualization to make it easier to start a project here or to start an application here. So for instance, you see here the connection to a web client, and you see in this lot of boxes here that you get a header response message, or and here downwards you see the respondent content. So it's with those examples, it's quite easy to start an application. Next is the MQTT client, and I want to tell you a little bit about what MQTT is. MQTT is called Message Queuing Telemetry Transport. So what is it? This is an open source publisher subscriber protocol and classically used for machine-to-machine communication. And it transmits so-called telemetry data as messages between devices. And what looks such a setup, or how looks such a setup? So in the center, you typically have an MQTT broker, which is nothing else than a server holding a database with the current state of all connected MQTT clients. And that's important information, because customers often ask, do you support subscriber and publisher, because we only read MQTT client, and in the language of MQTT, subscriber and publisher are all called MQTT clients. So that's important to know. So an MQTT client can be a publisher or a subscriber, and publisher could be a controller, of course. Typically is often a sensor, so a value you want to publish, and this value is published to this central database, the MQTT broker. And if any MQTT subscriber client subscribe to that so-called topic, temperature, for instance, he gets a message as a new value for the temperature is available. So if you need more information on MQTT, then you can, for instance, visit this website. And what we provide with our MQTT client library is a library to make a controller, or to enabling a controller to publish and receive data from an MQTT broker. So you can be an MQTT publisher or an MQTT subscriber. The function blocks we there provide are able to establish a connection to such an MQTT broker, and that is called an MQTT link. And then, of course, you have function blocks for publishing messages to the broker, for subscribing to messages or topics from an MQTT broker. And we, of course, support encrypted communication via TLS, and therefore it's also needed that we can handle client certificates from the MQTT clients. We support quality of service there, so it's very important, for instance, in the process industry, to know the quality of a value. And also with this library, a simple sample project comes up, and it includes the setting up of an MQTT broker on a Raspberry Pi. There's a little example for that. And of course, a visualization where you can send and receive messages with different publishers and subscribers. Then we have a library called mail servers. And the use case is quite simple. So it enables a controller to send and receive emails via SNTP and POP3. So you can establish SNTP and POP3 connections. You can send emails via SNTP. You can receive emails via POP3. You can delete emails on a server via POP3. And also here, encrypted connections are supported via TLS and SMTPS. And also here, sample projects comes up with visualization for a simple email client. And you see here, you can put an email address here, even a blind copy or carbon copy. You can write your text here and then simply send it to the email address. And the next quite simple library is called SMS service, and it's actually the same like the mail service. So it's a simple library providing the possibility to send and receive SMS if you have a available GSM modem on your controller. So it's includes a sample implementation for establishing the connection via modem. You can send such an SMS to a receiver. You can receive short messages from a publisher. You can even delete short messages on a device. And again, we have a small sample project with a visualization for the message handling. I cannot see your chats at the moment. So if you have questions, feel free to ask, but at the moment I'm in this modus where I cannot see your questions. Maybe I can.
Yeah, Anja, this is Marcus.
Yeah.
We actually have a couple of questions in our questions and answers section.
Okay.
Maybe I can just read it to you if you don't see it on your screen. And one of the questions that we have here from Garrick Reichert is what MQTT payloads are supported with the MQTT client. I'm not even sure in what direction that goes, but I guess it's depending on what kind of MQTT communication we can establish here.
I'm not sure about that, to be honest, but I think it's in the data sheet. But I can answer this question afterwards.
Sure.
Yeah. Now I see the questions. So the
Excellent.
next one is the CODESYS IoT platform integrated with AWS, Azure, Google, or it has its own based on your automation server solution. I mean, it is no IoT platform here. We have a set of libraries with which you are able to communicate with those services. And I will go on in detail with those cloud platforms later on. So our automation platform is not a solution that is placed against those services. It's it's a whole system that plays together. So the automation server has nothing to do with Azure or Google or AWS. I mean, it's hosted on AWS, but it has nothing to do with those libraries. So those libraries are make it possible to make a controller communicate with those cloud platforms, and that's the reason why we have it here. then the next question is, does it matter what quality of service is set on the MQTT broker side? No, you define the quality of service on the client side. So the client defines which quality of service is needed. There's a question if for certificate management it's possible to trust a certificate from a certificate authority. That is possible via additional plugin, and this is called the CODESYS Security Agent. So this is a plugin which is, or add-on to the CODESYS development system, which is also available in the CODESYS store. And with this plugin, it's possible to handle the certificate management. And another question is, so if I understand correctly, there are libraries available that can assist to integrate to any platform you mentioned earlier. Yeah, I mean, what you need is a CODESYS control, and this can be on the one side a controller developed with our product, the CODESYS runtime toolkit. So you can develop your own CODESYS controller, and of course you can use our ready adapted or fully adapted CODESYS controls, which are also available in the CODESYS store. So it's, for example, the CODESYS control for Linux, x86, or the CODESYS control Win, or the CODESYS control runtime, real-time environment, RTE. And if you have a CODESYS controller, you can build up an application with those libraries. And of course, for some protocols, some components have to be there. They're usually in some runtime components in our CODESYS controls. They are usually ready for all of the IoT libraries. But when you have a controller from a device manufacturer, it may be that there are some restrictions, but that's all placed in the data sheets. So which runtime components are needed at the end. Okay, then maybe I will go on with my talk. So let's go on with SNMP. So we have a library in there named SNMP service. So SNMP, it's stands for Simple Network Management Protocol. And it is a protocol for collecting and organizing information about managed network devices. So usually routers, switches, printers, and it is a protocol that is really widely used in network management and for network monitoring. So usually you have an SNMP manager, which talks to different devices, which could be a server, a router, a hub, or printer. And this manager usually sets requests to those agents. Here's a typical setup with the master agent collecting data from some sub-agents, or you can have an agent directly talking to the manager. And it's always about that the manager sends requests to the agents, and the agents make the response. And the agents can also set up so-called traps that is usually used for status information or for errors. So that is a message that is not requested by the manager. And the use case is, of course, making a controller ready to use to read device information of those network devices via this SNMP protocol. So with the library, you make your controller ready to request values, to request the value and get the so-called object ID from the next value. You can request values from the control agent. You can send and receive such trap or inform telegrams or reports. You can set values by SNMP. And also this library comes up with a small sample project with visualization for the status information and for sending and requesting data. So here you can see my IP address of the agent, your own IP address, see a value here and send the value, for instance. Next one sounds quite close, is the SNTP service. So quite similar to the last protocol, but actually something completely different. SNTP stands for Simple Network Time Protocol, which is a simplified version of the Network Time Protocol, NTP. And this is a library for synchronization the time via UDP, TCP, with a central server. And this SNTP software offers a simplified time synchronization solution, especially for computers with much less processing power. So it consumes less resources actually. So SNTP is a stripped up version of MTP for small controllers. And the typical setup is here you have this SNTP server synchronizing with the central time, and the clients can also synchronize with those central time. Yeah, the use case is simple, synchronizing the time via this protocol. And the functions we provide with this library are function blocks for easy implementation of such an SNTP client or server. So you can request a time of an SNTP server, so usually UTC. You can send the local time, and again, a sample project comes with this library with a visualization for requesting server time and detecting the time differences. So here is a little visualization example. You see here above the server time, you see your local time, and here below you see the difference between the time zones, and you can enable this button here to get the latest server time. And here's again the questions about SNMP, and it's called can I or data from the CODESYS program be sent via SNMP? Let's come back. Yes, of course. In principle, you can send any data you like via this protocol. That's possible. You just need to use those function blocks within your application, and then it's possible to send those values. And is this client capable of store and forward capabilities? I don't know which client you mean. Maybe you can define, or you can make your question clearer later on. Okay. Now we come to the topics we talked about before, namely the connections to so-called cloud platforms or cloud services. And we provide libraries for the most important cloud platforms. Let's start with AWS. We have a library called AWS IoT Core Client. What is AWS IoT Core at the beginning? So AWS IoT Core is a managing cloud platform from Amazon for connection of devices, and they can work easily together and safely, of course, with the cloud applications provided in this platform, on the AWS platform and other devices. And so the AWS IoT Core is this central service on the AWS environment. And of course, any devices can publish and subscribe messages to this central service, and the service can send messages to any device who wants to communicate with. And more information you can also get here on this website. And with our library, we enabling the controller to exchange messages via this AWS IoT Core service. So we make it possible to publish and subscribe messages based on the MQTT protocol. So in the background of this library, our MQTT library is used. And for communication, we support TLS encryption and therefore also authentication via client certificate. Also here we support quality of service, and with the AWS IoT Core Client, a little sample project comes up with visualization demonstrating the reading or writing of a called device shadow. So the devices are represented in this AWS IoT Core service as device shadows, and what you see here, for instance, are the connection settings. Then you can subscribe to any device shadow changes. You can read the device shadow, or you can even update the device shadow. So via this library, it is possible to send and receive messages for any device placed in this AWS IoT Core service. The next quite important player is, of course, Azure, and therefore we have a library called Azure IoT Hub Client. So what is the Azure IoT Hub? It's basically the same as we heard before, but it's done by Microsoft. So it's also a managed service, a cloud-hosted solution backend for bi-directional communication between IoT devices and Microsoft Azure Cloud Platform. And it's the same in here. You have security, enhanced communication, you have a built-in device management, a fully integration with other Azure services, and of course compatibility with the Azure IoT Edge devices. If you need more information, then please visit those websites by Microsoft. The IoT Hub Client is the use case also simple, so exchanging messages with the Azure IoT Hub service. You can then send and receive messages via HTTPS and MQTT. You can read, update, and subscribe the Azure so-called device twin, and you can perform direct method calls. You can, it's also included a little getting started for setting up such a cloud service on Azure, and we bring a sample project with the visualization for communication with the cloud service. So here above, the connection settings are done. Then you can define messages and make a direct method call. You can subscribe to any device twin. So we have a little UI for getting the FBs ready. And the next big player on those cloud platforms, of course, is Google. And therefore, we provide a library called Google Cloud IoT Core Client. So Google Cloud IoT Core, it's actually the same. It's, again, a fully managed cloud service from Google. to connect and manage data from the connected devices. And in the center of the service is a so-called device manager. And device manager is registering any devices with the service. And then via MQTT and HTTP, you can communicate with any devices with the central management server. More information you can get here from Google. So our library makes it possible to exchange messages with those Google Cloud IoT Core service. You can send and receive messages via HTTP and MQTT. You can send events and the device status. You can receive any device configuration and commands. We have MQTT client in there for the MQTT bridge broker. We support encryption algorithms for RS-256 to create so-called JSON Web Tokens. We come to that later on. And again, we provide here a simple sample project with a visualization for HTTP and MQTT-based communication with the cloud service. So, as I mentioned before, so you have to be able to create so-called JSON Web Tokens, and therefore we also have a library. What is a JSON Web Token? A JSON Web Token is actually an open standard that defines a compact and self-contained way for securely transmitting information between parties as a JSON object. And this is what a JSON Web Token looks like. So this is the encoded form, and here you have the decoded form. So you have here above a so-called header, which basically has the algorithm in there and the token type. Then comes the payload or data, and at the end you have your verification signature. And our JSON Web Token library makes it possible to create such a web token on a controller. So with the library, it is possible to create signed JSON Web Tokens according to RFC 7519. And we support the different signature algorithms stated here. And again, we provide this little sample project visualization for creation of the JSON Web Token. So you can define a header here and the data you want to set. Then here you can decide for the algorithm you want to use. You can give a name, and then with execute, the JSON Web Token is recreated on the controller. And there's a new questions. Are these various IIoT related libraries and associated examples part of the package, or they are available for free or for cost trial version? Okay, yeah, all those libraries and the example projects are available as one package called IIoT libraries, and you can download and try them for free. So there's no trial version for 1 month or so available. You can use the libraries and the example projects and download it to the controller. And for those libraries, the demo modus is, or the trial version is that they are running for about 30 minutes. So then you can stop your application, or the application stops, and you can restart your application and try again. So the trial version is 30 minutes. This is for free. And if you want to go on working with those libraries, then of course you have to purchase the full version. And I will come to that topic later on also. Then we have a library called JSON Utilities. So what is JSON? JSON is called JavaScript object notation. And this is a lightweight data interchange format, and it's really easy to read and write for humans, for machines, to parse and generate. So this is a very, very important format, and this is usually used as a message transfer format in cloud services. So all those communications with the cloud platforms I showed you before, so with Azure, AWS, Google, is usually done in JSON format. And here below, you see this JSON format, and in the right here is a little example, and here you see that's really quite easy to read and write, and yeah, that's a typical way to community with cloud platforms, with web servers, with REST APIs, and yeah. And we provide with the JSON utilities a library for reading and writing data in JSON format. So you can read and write JSON files in UTF-8 and 16. You can also read and write JSON byte arrays. You can search for keys, values, child and parent elements. You can, we provide a sample project also with visualization for reading and writing such JSON data. So here's a little example placed here. There's a little table with a JSON from a message that's read it, and you can also write in a little text box here a JSON data and send it somewhere. And a simple REST client, for instance, can be implemented together with the library web client. And there's a question, is JSON comparable to XML? Yeah, at least, of course, it's another text-based interchange format. It's comparable. But I would say JSON is much better to read and write, and it's it's also a standard in the communication with those cloud platforms. So XML takes not so much place in this communication with those platforms. And at the end, we have also some file utilities. So I did this on one slide because it's always the same. So we have libraries for reading and writing CSV and INI files. So you can exchange data structures with those libraries. We have function blocks for reading and writing XML files or strings. And with XML, it's also possible to find elements by name and attributes. And also with this libraries, little sample projects come up with visualizations for making this file exchange possible. So, and then let's come to the question that was stated before. How can I buy this product? So there are two possibilities. On the one hand, you can buy a so-called single license, which is always called SL, so single license, as an add-on for our CODESYS controls. So you can buy any CODESYS control and on the CODESYS store, and if you want to use the IIoT libraries, you simply buy such a license for your controller. You need the license on any controller, but you need only one license for all the libraries I showed you. So all communication protocols are licensed with this one product. So you don't need an license for MQTT and for AWS and for Google and for Azure. So it's all covered by this one license. Maybe you saw that we had a different business model before. Before we sold all libraries as separate products, but we changed that. And now we have this general license, this general IoT libraries license for all of the communication protocol. And on the other hand, you have the possibility as a device manufacturer, so of a customer of our product called CODESYS Runtime Toolkit, to buy those library bundle or this license as also as a platform buyout, as an add-on for your runtime toolkit. So, and if you want to try those libraries, just simply go to the US store and put IoT in there, and you see here the IoT libraries. You can buy them here for one device for $60, single price. Of course, when you buy more license for your controllers, you get a discount. And you also have the descriptions of all the products here. And together with this package, a lot of data sheets come up. So about every library and every example project, a data sheet is provided, and also online help, which helps you to build up your application. And the download is always for free. So when you have signed in, when you have an account for the CODESYS store, you are able to download and try the libraries and try to build up an application, running it for those 30 minutes I mentioned. And when you then buy such a single license, of course, you can fully run your application as long as you want. And there are some questions. So what is the name for the library for generating CSV files? This is CSV utilities.